Imagine walking through Europe's oldest cities. Historic buildings stand exactly where they've stood for centuries. Suddenly, the temperature climbs above 40 degrees Celsius. Down at street level, the physical environment begins to give way. The asphalt on the roads actually softens and melts under the intense thermal pressure. This heat forces immediate emergency halts to movement. Transit networks are disrupted, and authorities advise the public against any travel that isn't absolutely essential. Cities in the Middle East and the American South routinely manage these temperatures, yet here they trigger a systemic collapse. The crisis is a direct collision between rising temperatures and a built environment engineered for a completely different world. Hundreds of years before modern heating existed, these cities were planned with one primary goal: to help their populations survive long, freezing winters. Builders achieved this by using thick stone walls to retain warmth and designing narrow, winding streets to block cold winds. Under modern extreme heat, those exact features behave like thermal batteries, absorbing the heat and holding it in the stone rather than letting it escape upward. The engineering that once protected these populations from the cold has transformed into a mechanism for trapping them in an urban oven. The same heat that settles into stone walls also works its way into the physical networks connecting these cities. Under thermal pressure, solid steel railway tracks expand and physically bend out of shape. When tracks warp, the transportation grid freezes. Trains stop running, paralyzing movement at the exact moment populations need to reach cooling centers or medical care. Rising temperatures alter the physical properties of a country's logistics, forcing entire economies to a halt. As heat becomes trapped, millions of people simultaneously turn on air conditioning units to survive, causing electricity demand to spike. Grid operators face this surge in demand at the exact moment the heat makes it harder to generate electricity. Nuclear plants rely on nearby rivers for cooling. When river water becomes too warm to safely cool the reactors, these plants must reduce their electricity output. Simultaneously, hydropower suffers as heat waves trigger droughts that evaporate the water reservoirs these dams rely on. Extreme heat chokes off the supply of electricity exactly when the population requires it the most to survive. Beyond the power grids, the heat directly targets Europe's agricultural landscape, one of the most productive in the world. Prolonged heat waves accelerate crop dehydration, forcing farmers to deplete shrinking water reserves for emergency irrigation. These conditions threaten livestock and lead to severe, widespread reductions in total harvest yields. Because global food markets are integrated, a reduction in European harvests directly drives up the cost of groceries worldwide. A local heat wave becomes an active threat to global food security and pricing. While these failures happen locally in Europe, the economic effects reach into North American wallets and supply chains. North American supply chains are tied to European manufacturing hubs through a dense network of trade routes. When European power grids fail and railways melt, manufacturing slows. That instantly delays shipments across the ocean. This production slowdown results in supply shortages and price increases for businesses and consumers across the world. Climate events no longer respect borders. A local heatwave mutates into a global financial shock. Europe is currently attempting one of the largest and most expensive infrastructure retrofits in its history. Cities are deploying redesign strategies on a commercial scale, such as painting massive expanses of roofing white to reflect solar radiation. Natural cooling infrastructure is being integrated into ancient spaces by tearing up pavement to plant urban forests. During peak temperatures, cities rely on emergency adaptations, from cooling centers to public water features to keep citizens alive. While governments are active, adapting centuries-old infrastructure is a race against time and rising temperatures. This crisis is a stress test for the rest of the world. The vast majority of major cities were engineered for the climate of the 20th century and will soon face this same breaking point. Moving forward, economic survival will depend on how well a nation can secure its energy, water, and transport under thermal stress. The next global economic shock won't be a sudden crash. It will be a slow, creeping structural failure, arriving 1 degree at a time.